Good morning. Now we are going to see the relation between mass and energy. Why this relation is important? What is the significance of mass-energy relation? E equal to mc square. Something out of nothing. This relation is probably the most recognized symbol of physics. Physics is the study of matter and energy. Because everything in the world made up of matter. Matter has mass. This mass may be converted into energy. On the basis of special theory of relativity that mass and energy are both but different manifestation of the same thing, which means that when you have a moving object, it is more massive because it has more energy. That means energy equal to mass times the square of velocity of light, because c square is such a large number. This relation also showed that a small amount of mass is converted into large amount of energy and vice versa. How the sun generates the energy? What is the fundamental source of energy? In 1905, Albert Einstein gave the relation or discovered the key to the element. Sun is the main source of energy and heat in the solar system. Without light energy from the sun, there would be no life on the earth. All of the energy reaching earth from the sun ultimately comes from the nuclear reaction. The relation E equal to mc square forms the basis of understanding of nuclear reaction such as nuclear fission and fusion. The nuclear fusion is a nuclear reaction in which two or more light nuclei collide at very high speed and join to form a heavy nucleus. The mass of the heavy nucleus is less than the sum of the masses of light at once. Here some mass is missing. This missing mass is converted into energy according to the relation E to mc square. Next reaction is nuclear fission. The breaking of heavy nucleus into smaller nuclei. The mass of heavy nucleus is greater than the sum of the masses of light at once. Here also the missing mass is converted into energy due to the relation E equal to mc square. Now derive an expression for relation between mass and energy.
Consider a body of rest mass m0. A force F is acting on it in the x direction. According to Newton's second law of motion, force is defined as the rate of change of momentum. That is, F equal to d by dt of mv. According to the theory of relativity, both mass and velocity are variable. Therefore, F equal to m into dv by dt plus v into dm by dt. Let the force F displace the body through a distance dx, then the increase in the kinetic energy of the body is equal to the work done, that is F into dx. dk equal to F into dx equal to m into dv by dt into dx plus v into dm by dt into dx. Now dx by dt is nothing but v. Now substituting the value of v in this equation, we get dek equal to m into v into dv plus v square into dv. In Newtonian mechanics, mass, time, length and space were treated as absolute. But in Einstein's view, there is no absolute space and all motions are relative. The time, mass, length and the space are interdependent and are not absolute. Therefore, Einstein established the relation between the mass of the body at rest m0 and the mass of the same body moving with velocity v is m equal to m0 by square root of 1 minus v square by c square. This is the law of variation of mass with velocity. Squaring on both sides, m square equal to m0 square by 1 minus v square c square. m square c square equal to m0 square c square plus m square v square. Differentiating this equation, we get c square 2m into dm equal to m square 2v into dv plus v square 2m into dm. Removing 2m throughout the whole equation, we get c square dm equal to m into v into dv plus v square dm. Comparing the two equations, dEk equal to c square dm and mv dv plus v square dm. From we get dEk equal to c square dm. Thus, a change in kinetic energy is directly proportional to change in mass, that is dm. When the body is at rest, its velocity is 0, kinetic energy 0, and the mass m becomes m0. When its velocity is v, its mass becomes m. Therefore, integrating this equation within the limits 0 to Ek for kinetic energy and m0 to m for mass, the result is Ek equal to mc square minus m0 c square. This is the relativistic formula for kinetic energy. When the body is at rest, the internal energy stored in the body is m0 c square. m0 c square is called the rest mass energy. The total energy of the body is sum of kinetic energy and the rest mass energy. Then V equal to Ek plus m0 c square. Now substituting the value of Ek in this equation, we get E equal to mc square. This is Einstein mass energy relation. This relation states that universal equivalence between mass and energy. It means that mass may appear as energy and energy as mass.
Example for this reaction is phenomenon of pair production and annihilation. When an electron meets its antiparticle positron, both of them annihilate and forms two photons. Since the total energy is conserved, the total energy associated with the electron and the positron is transferred to photons that have no mass. See, also energetically photon can create electron and positron with mass. These are the examples for Einstein mass energy relation. Hence the statement mass energy equivalence comes true. Thank you.